All right, let's go ahead and get started. Um, so before we get back into things, I wanted to bring up a couple things I saw in the homework that are pretty widespread. Most of you did very well in the first the water over that. Um, one was a lot of you were so that kind of suggests read. Yeah, the pool is 5 feet high. Girls were kind of in displacement. Um, Another thing, when you're dealing with pounds, there's no reason to bring in the acceleration of gravity. Is a unit of product of force and distance. If you're dealing in pounds, you're already dealing with a force. Um, Dealing with metric units, mass, then you have to deal with the acceleration of gravity. But a lot of I don't know, maybe 8 or 10 of you multiplied the weight. One thing I wanted to show you here was I didn't really have a good demonstration of the squeeze theorem. So I wanted to revisit one of our examples from last time. So we said this thing converges, right? But now what I want to talk about is how we can use the squeeze theorem to make this clear. So if we write out a few terms here, or kind of what this thing looks like, what does n factorial look like? N times n minus 1 times n minus 2, all the way down to times 2 times 1. All over, what does this look like? N times n times n times n, and so on. So something I would like to do here, I'm going to rewrite it like this. I'm going to pull out the n over n. So if I pull that out, here are two things that two claims I want to make. Can I say that a sub n is always going to be positive? Or all the terms in the sequence can be positive? Okay, so I'm going to do this. I'm going to say that this is true. So this sequence is always, always, always greater than 0. Another claim I want to make is this. Is this going to be bigger? Or is this going to be, bounded above by 1 over n? And that's 1. Is what remains going to be. So if that's the case, then basically what I'm trying to do is this. I'm trying to find the limit as n goes to infinity of a sub n, which is something that maybe I can't do directly, but what the squeeze theorem allows me to do is this. I know that this is a sequence that is always smaller than a sub n, and this is a sequence that's always at least as large. And I think we talked about last time, maybe it kind of caused some problems. I have a sequence where all the terms inside that sequence are just. So they're called constant sequences. They're totally, yeah, they're valid. They're not always interesting, but sometimes they're useful. What can I say about the limit as n approaches 0 or infinity of 0? That has to be 0, right? The terms never change. What's the limit as n approaches infinity of 1 over n? Also 0. So that means that any sequence that's always kind of stuck between them. So basically, these two things guarantee that the limit of the middle sequence essentially is also 0. So I think there are a couple questions on both the written homework and online homework here. Any questions? Okay, so if I rewrite this, let's look at a couple of terms here. So let's do this. Let's write out the first few terms of A sub n and the first few terms of 1 over n. So what's the first term of A sub n? 1? 1 over n? Okay. These are way easier to write out, right? Okay. So what about, what's 2 factorial over 2 squared? 1/2. What's 3 factorial over 3 to the third? 6 over 27. We get harder and harder, but let's do one more. What is 4 factorial is 24? 4 to the 4th is 256, I think. So the first two terms are identical, right? And what's that? As in both, so they're both decreasing towards 0, decreasing at a higher rate. Can we get a decimal representation for 6 over 27? It's 3 over, no. Is it 2 over 9? Okay, as opposed to 0.3 repeating. This is 0.25, 24 over 256, not even gonna try that. I can see though it's less than a 10. So I think that's probably the most direct way to see that bounding is there. Is that they start off as equals, but you know, as n gets larger, you're going to see the A sub n decrease at a faster rate. Yeah. I mean, might not make sense why you would do this, but then maybe I could say this is 1 over radical A. Basically, yeah. So it's very much up to you. But here's the thing. We're trying to find out if this middle sequence converges, right? So if you're going to try to bound it below and above by other sequences, those other sequences should be things that you understand a lot better. So you don't have to say that converges. 1 over n is once that I is truly. Okay, I think I mentioned last time the test is coming up, right? I think it's a week from today. So 8.2 is the last section we're gonna do, or 8.2 is the last section that's gonna be on the test. I'll go over 8.4, but after that, I'm not gonna go any further. It remains between 8.4 and the test. Go ahead. I'll go look it up, but I think it's all of chapter 7 on. I'll make sure of that. Okay, so we're talking about sequences for the last, a little bit over a day now. Now, what does it mean to, what's the difference between a sequence and a series? How do we deal with those? So if a sequence is essentially a list of terms, basically an ordered list of terms, then what is a series? A series is that's kind of the end game, but let's talk about and kind of the series, all the terms in that sequence. We can sequence of partial sums. So I can make another sequence out of a sequence that sums up the first however many terms of the sequence. So this, let's say I had S of 6 here. Then what I'm really doing with S sub 6 is adding up. I don't know why I chose such a big number, but you're adding up the first of the first 6 terms. So any the two. So this thing right here, I want to know if this series. So let's talk about the notation. Have we seen this symbol before? Um, so the index that we pretty much exclusively use when we're talking about sequences is n, right? So what job is this I doing right here? It's your first value, but let's say I write something like this. If I write the summation with I equals 1 to 4, like there's just an n up here, right? Of a sub I. What is this sequence, or what is this notation representing? You already said that I'm adding up some stuff. Okay. 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 So my endpoint, my kind of ending terms are, or my ending indices are 1 and 4. So what am I really adding up here? A1, right? So, okay. So I wanted to make sure that we had the middle ones as well. But yeah, so we are basically adding up all those terms. So this 2n over 3n plus 5, what is that? Is that a term in the sequence? Nth term in the sequence? Or what does it really represent? Basically, this is the board book. New notation. This does not represent any single term. Are we saying that 2 times over 3 times? That's what why I want to kind of really nitpick this thing because that's not what a sub one said. In this case, so let's just talk about all these things are equal, right? How many equal signs do I have here? 1, 2, 3. So all four of these things need to be saying the same thing, right? So let's start with the summation. That's kind of a new thing. We said that, for whatever the value of n is, add up that sequence, right? So typically use lowercase n to talk about a certain sequence, and that is a sequence of partial sums. So let's do a couple things here. Here's a sequence. I don't know anything about this sequence, except I can name the terms A1, A2, A3, and so on, right? So that is kind of like my base sequence. So what does the sequence S sub n look like? What's the first term in S sub n look like? So what's S sub? It's just A sub 1, right? What's okay? Why is it A sub 1 plus A sub 2? Right. So basically, A sub n is just some sequence that is identical in structure. S sub n is a new kind of sequence that basically makes partial sums of the above sequence. So what does S sub 3 mean? S sub 3 means I want to add up the first three terms. What does S sub 35 mean? I want to add up the terms. So any questions in the, so the connection between a sequence and partial sum of that sequence. It's a subtle difference, but it's very important. So if we need to talk about it, we'll talk about it. All right. So if we add n terms together, we get this. So now we're building up to this thing. The sum from 1 to whatever n I have. If I add up all those, if I find the nth partial sum, it'll equal this. 2n over 3n plus 5. List of terms, right? Is first three. I don't want to write sub 1 through 8. Not so a couple ways to look at that. Basically, I know the partial sum for any value of n is given by this 2n over 3n plus 5. So I can look at if this thing converges. What's the limit as n goes to infinity of 2n over 3n plus 5? Can we say that? Or is that a limit we can evaluate? Would it be 1? Both the numerator and denominator. Right. So let's do a manipulation here. Is it legal for me to multiply a numerator and denominator by 1 over n? Hopefully you agree that that's legal. But if I do that, what do I get? I get the limit as n goes to infinity of 2 over 3 plus 5 over n. How do you feel about that? Is it more convincing that that goes to 2/3 now? So this series converges. If you were to add up all the terms or sequence, that shows up to questions here. Not so much about yeah, we can talk about how we got that, but I think the new stuff here that I'm concerned about is stop me here stuff. So we talked about a sequence like this last time, right? What kind of sequence or what kind of sequence is going on here? It's a geometric sequence, right? What were the conditions we put on R for a geometric sequence to converge? Remember? I think we said that R had to be bigger than -1, less than or equal to 1, right? If R is equal to 1, you just over again, right? If A is equal to -1, it alternates, which means it can't converge. So under these conditions, the sequence converges. Now I'm asking a slightly different question. Under what conditions does the series converge? We think it's the same set of R values. So assuming A is non-zero, let's just pick a value for R. If R is equal to a half, so let's somebody give me a value for A. 2 sounds good. Someone give me a value for R. 3. Let's pick one we know converges. 1/2 sounds good. So let's start writing out the terms in this sequence. 2, then 2, 1, 1/2, 1/4. Do we think this sequence converges? Better, right? You told me that if R is between -1 and 1, that this thing converges, it should converge to 0. So here's the next question. Does the series converge? If I were to add up all those things, 2 plus 1 plus a half plus a fourth, and so on, do we think that sequence would converge? Or series, sorry. In fact, it would. So we're going to slightly alter the criteria on R here to meet this. -1 is less than R, which is less than 1. So what's the difference between that? Equal 1. Why are we removing that? So let's go back to our sequence. If we say A equals 2, R equals 1, then what's the sequence going to look like? 2, 2, 2. Can that series converge? Why can it not converge? All right, the sequence converges, but why does the series not converge? Keep adding 2, right? Here's an idea. You have a series that converges. So the infinite sum exists. The infinite sum is real. About the sequence. So in a series, you're basically So that's something we'll talk about in more detail in a little bit, but hold on to that thought. So big big takeaway for geometric series is that they converge when R is strictly. So this is kind of exactly what we did. Let's look at one of these series. When I find the sum, well, do I even know that the sum exists? How can you convince me the sum exists? Okay. Okay. So you're saying this is a geometric series has a common ratio of -2/3. So those two facts alone. But what does it converge to? So this is not a thing that I'm planning to derive, but if I have a geometric series, then I can find its sum this way. The infinite sum is equal to the first term divided by 1 minus the common ratio. Just to be really clear, I got to write this down. What's the restrictions for this formula to hold true? R cannot equal 1. Well, there's more we have to. If R equals 5, but it's nonsense. So if I say this sum, so this sum, infinite sum exists, right? Then what has to be true about R? It has to be between -1 and 1. So just be careful. I mean, formulas are only useful if you know when they're applicable. So now can we find the sum of this series? What's A1? 5. What's my denominator? 5/5/3. So the infinite sum of this series should be. How did we get 5/3? 1 minus the common ratio. So 1 2/3 is 5/3. Is this thing convergent or divergent? So instead of listing out the terms, is there any way we can make sense of this? Gotta prove this thing is geometric. So we might just rewrite. So let's do this. We did not do this, but can we come up with a formula for this sequence? So I'll write it down as a sequence: 5, -10/3, 20/9, -40/27. Can I come up with a name or a formula for this sequence? So if I know a term in the sequence, how do I get the name? A1 minus what? So put the R in front of A1. No, that's the series. So right now, I'm just trying to come up with a formula, like basically define the function for the sequence. A R to the n minus 1, like that. Okay. Can I be more specific about this sequence? What's the A? 5. What's R? -2/3 n minus 1. Is this going to give me all the terms in the, if I just wanted to get a term in the sequence, is this going to work for the 4 that I know about? When n equals 1, that should be 5. When n equals 2, this should be 5 times -2/3, and then 5 times negative, and so on. So I think this works. If I were to have given you it in that form, would that have been clear that it was geometric? So I'll ask the question again: what is a geometric? The sequences. What separates geometric sequences? I'll multiply by number to get the next number. Okay. So that common ratio is 2/3. And as n increments, I'm just multiplying. So I think if you have this, basically this template, it has a common ratio raised to some exponent, or not any of the exponent that defines the sequence. So we need to know what the common ratio is, but it has one. So can we rewrite some of these? I would really love it if I get to a place the only exponent. Is there any way for me to rewrite 2 to the 2n? Is that true? If I have a power raised to a power, I can coordinate off like that. How about 3 to the 1 minus n? You're saying it's 3/3 to the power of n. How'd you do that? I agree, but is it clear why that works? Right, so let's break this down. Let's go, you were so used to going the opposite way. What's x to the 4th times x to the 7th? How'd you get x to the 11th? You add the exponents together, right? It's very uncommon that we go the other way. But so 3 to the 1 minus n is equal to 3 to the 1 times 3 to the negative n, which is equal to 3 over 3 to the n. Okay, so what did we just do? I think we found a way to rewrite this series as 4 to the n times 3 over 3 to the n. Do we have any votes yet on whether this thing converges or diverges? I have a to the n over b to the n, and I say this is true. Okay, that's in fact true. So I am going to rewrite this one more time as 3 times 4/3 to the n. Right, r is supposed to be between -1 and 1, right? R is equal to 4/3, which is greater than 1. So what does that mean? Diverges. And we can see that if we look at a few terms. So let's start writing out this series. I think the first term will be 3 times 4/3, which is 4. What's the second term? 3 times 16 over 9, so already getting out of hand. 3 times 16, 48 over 9. What's happened to the terms already? They're getting larger. You're going to have no hope of this series converges. You're converging all the sequences. Okay. All right. So I have a drug. I'm trying to come up with a sequence for basically how much of this drug is in their system at any given time. Of this drug in this person's body in 3 days. Let's look at after the first day. So let's try to build this sequence up kind of from the ground up. What is, after the very first dose, what's the concentration of this drug? Yeah, but so a couple things we have to worry about. After any given dose, after the first dose, that's going to be. So the concentration after the first dose should simply be what it contributes. 0.2. How about after the second dose? I'll do 0.26. So 0.2 plus 0.3 times 0.2. So gonna have 30%. you know, what we and plus the 0.2 milligrams per milliliter that comes from. Right. Can we say something about the third dose now? So again, we're going to add 0.2, right? Point 0.3 multiplied by the previous term, right? So what is that previous term going to be? 0.2 plus 0.3. So all these things are kind of nesting together, right? You're this stuff. Right? Zero 0.2 plus 0.3 times a sub n minus 1. So we have this recursion going on here. You okay with that? Okay. So I think we've got the first two bullets. Any questions so far about where we are? But I think as we've defined it, I don't know if this is a geometric sequence. It has elements, but is there a way that we could maybe so maybe it would be helpful if we wrote out these terms. So we said 0.2 and then 0.26, right? Let's go ahead and work out the next one. Yeah, 0.2, 0.26. I got 0.278. Is there a common ratio that joins those things? So we've kind of said that there are two elements of this sequence. There is something, right? There's also something multiplicative, right? So this additive component is 0.2. The multiplicative component is 0.3, 30%. What if we build up a second sequence where we're just looking at kind of the differences of basically if we kind of we're irrespective of that additive component. So I'm going to subtract 0.2 from all these. So 0, 0.06, 0.078. So I don't think I can have a geometric sequence to start. If I remove the 0. So I think you're onto something, but how would we write that out, define it? Right. Right. And like right now, I think we're trying to decompose this into something non-geometric and something geometric. So here's what I propose now. Can we get the next, let's get one more term in this sequence. So basically, can we get the fourth term in this a sub n that we made? And I think based on this formula here, we should be able to, right? So r equals, we said 0.3. What is a sub 4 equal to? A sub 4 is equal to 0.2 plus 0.3 times 0.278, right? Got 2834. So this will be 0.0834. Now, what do we think about B? So if I were to, let's delete 0 from it, and I think we're going to have to pick this up on Wednesday. Let me ask you one more quick question. Do we think this sequence B sub n, disregarding the 0, is this thing going to be geometric? Would I have to multiply 0.06 by to get 0.078? Does that hold true for here too? 0.078. Never mind. Okay, so we're not getting a geometric sequence. So let's revisit this on Wednesday. But there is a geometric sequence to be found here, even though it's obviously. All right, I'll stick around if you have any questions. Otherwise, I'll see you either office hours tomorrow or class Wednesday.